In this last part, I'm just going to do a few applications of systems of equations. One application, this is a physics application. You know how much I love physics. You have the position of an object moving with a constant acceleration is given by this equation, where s is the position of the object, a, as you might guess, is the acceleration, v stands for velocity. This little 0 means naught, N-A-U-G-H-T, which means initial velocity. It's the velocity an object starts out with. And s, remember, stands for position, so s naught is initial position. So the problem says, find the acceleration, initial velocity, and initial position if s equals 52 at t equals 0. Oh, sorry, and t represents time. So if s equals 52 at t equals 0, s equals 52 at t equals 1, and s equals 20 at t equals 3. So we're going to write a system and then solve it. To write a system for this situation, we just plug in the values we're given into the equation. So the first equation of our system, we just plug in s equals 52 and t equals 0. So that gives us 52 equals 1/2 a times 0. I guess I'm going to have to write that lower because there's a glare. 52 lower, 52, sorry, equals 1/2 a times 0 plus v naught times 0 plus s naught. So our first equation is simple. Just gives us s naught equals 52. Then we use our second condition. S is 51 when t is 1. So s is 52. That's equal to 1/2 a times 1 squared, which is 1, plus v naught times 1 plus s naught. So our second equation is just 1/2 a plus v naught plus s naught equals 52. And our third equation, we have s equals 20 at t equals 3. So 20 equals 1/2 a times 3 squared plus v naught times 3 plus s naught. So this third equation gives us 1/2 times 9, that's 9 halves a plus 3 v naught plus s naught equals 20. So now we have three equations that we can work from in order to solve this system for our acceleration, initial velocity, and initial position. I'm going to make some space here by clearing this off. Now, I've recopied my three equations over here. This is already set up for row echelon form. We just need to get rid of the a in our first equation. Instead of x, y, and z, now we have a, v naught, and s naught. Doesn't change how we solve it. To get rid of a, call this equation 1, equation 2, equation 3. To get rid of a, we can just take -9 times equation 1 plus equation 2. A's cancel out. -9v plus 3v gets us -6v, v naught. -9s plus s gets us -8 s naught. -9 times 52 is -468 plus 20 is -448. So now that's our second equation in proper row echelon form. So we can replace the equation that we have there. negative 6 v naught minus 8 s naught equals minus 448. And then use back substitution to solve. I'm going to be a smart guy and use my calculator. So if we substitute in here, negative 6 v naught minus 8 times 52 is 416 equals minus 448. 8 times 52, double checking, okay, good. And then we have negative 448 plus 416 gives us negative 6 v naught is equal to negative 32. So our v naught is equal to 5 1/3 or 16 thirds. And then we plug both of these values into our first equation, v naught plus s naught, 52 plus 16 thirds is 172 over 3. That gives us 1/2 a plus 172 over 3 equals 52. Take 52 minus 172 over 3 and multiply by 2. And we get our acceleration is minus 10 2/3 or minus 32 over 3. Alright, so now we have the three solutions of our system. And what do? As always, we check them in our equations. And if you punch those into your calculator, you will see that they work out. So our solutions then are s naught is 52, v naught is 16 thirds, and our a is negative 32 thirds. Since we don't have a standard for putting a v naught and s into an ordered triple, we just have to say what each one is, and we don't have a more convenient mode of representing them like we do for x, y, and z. One final application we can do with solving multivariable systems is to find quadratic equations. Find a quadratic equation if we're given 3 points that that equation passes through. We can use this format to get our system of equations. Passes through the point negative 1, 3. That gives us 3 equals negative 1 squared is 1. That's just a. Negative 1 times b is just negative 1, or negative b, plus c. And I'm going to swap this 3 over to the other side, just so that it looks more like our systems usually do. If we put in 1, we have the ordered pair 1 comma 1. Put in 1 for x, we get a plus b times 1 is b plus c equals y, which is 1. And the ordered pair 2, 6. 2 squared is 4. 2 is 2. Plus c equals 6. So there we have a system of equations to solve for our parameters a, b, and c in that quadratic equation. I'll number equations 1, 2, and 3, just like usual, and we can solve from there. To get rid of the a in equation 2, we can take negative equation 1 plus equation 2. Negative a plus a cancels out. Negative b, or sorry, positive b plus b gets us 2b. Negative c plus c cancels out. So then we just have 2b equals negative 3 plus 1 is negative 2. And we can simplify this to get b equals negative 1. Now here we have a shortcut. Because this worked out so that both our a and b canceled, we can make this our equation 3 and bump this one up to equation 2, and therefore only do one operation to it. Since this already has one variable solved for, we can make b our last variable instead of c. So this equation is taken care of, and this is our new equation 3, and we can call this one equation 2 instead. in order to get rid of our a in equation 2, we take negative 4. You can take negative 4 times equation 1 and add that to equation 2. Negative 4a plus 4a cancels out. Positive 4b plus 2b gets us 6b. Negative 4c plus c, so minus 3c. Negative 12 plus 6 is negative 6. Okay. Now I'm going to collect our equations together so they look a little bit nicer. I'm going to do that over here. Just copying them down. We now have our equations in row echelon form. We have a minus b plus c equals 3. We have, and I am going, because b was the one we have solved for already, I'm going to change the order of these so they look like our row echelon form. We have negative 3c plus 6b equals negative 6, and we have b equals negative 1. And from there, we can just do back substitution to solve for our c and a. We plug in negative 1 here. 6 times negative 1 gets us negative 6. We add that over, we have 0. So from our second equation, we get that c is 0. So then a plus 0 plus 1 equals 3. A plus 1 equals 3. So we get that a equals 2. So our solution is a equals 2, b equals negative 1, c equals 0. We want to double check that. In our original equations, 2 plus 1 is 3, plus 0 is 3, good. 2 plus negative 1 is 1, plus 0 is 1, good. 4 times 2 is 8, plus 2 times negative 1 is negative 2. 8 minus 2 is 6, plus 0 is 6. So our parameters check out, and our solution then is the equation y equals, there's a glare there. Our equation then is y equals 2x squared minus x plus 0.